Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Rios. What I will be presenting tonight will be the so-called solar power energy. In here, I got an inverter. Okay, the inverter is rated 600 watts. Inverter meaning it will change direct current to alternating current. The power supply of this inverter is actually a battery. This is the one at the back, the plus and minus. And this is connected to my solar battery, which is rated 12 volts, 45 ampere hour, a sealed lead acid battery. So this one is connected to the positive side of the inverter, the input. And this black thing is to the negative side of the inverter. So the the power input to the inverter is actually the battery. So for as long as the battery is charged, okay, this inverter will work. That's why solar energy is actually, we conceive it, meaning if we charge a battery during the day and we will assemble like this, so if we got a battery and an inverter, during a brownout or blackout, we could still, what do you call this, operate our AC operated electronic equipment. Okay? But the condition for this one is that the voltage output of the inverter should be sine wave. Sine wave. It is sine wave. It should not be square wave. Because if you are using a square wave and you are plugging in on electronic equipment like a big screen TV, which is digital, okay, you will be damaging that TV if the wave of the inverter is a square wave. Just just make sure that the inverter you are using, okay, the wave of the alternating current should be sine wave. Okay, I would like to show you now how this one operates. This is just my backup inverter. My main inverter is actually at the ground floor, and I use that to operate my washing machine and dryer. But for this one, I could use this one to operate my desktop computer maybe during brownouts. Because desktop computer needed alternating current to power up the power supply. And this is actually the outlet of the inverter. We got two outlets here. So if I will try to push the switch to the on position, you could see that this is green, right? It is alive because this inverter is now connected to the battery. So for as long as the battery is more than enough, okay, for this inverter to operate, it will work. But there are some inverters in which if the voltage coming from the battery is low, okay, they will try to sound up an alarm, and that's the time that you should shut off your inverter for it not to be damaged. That's a protection for the inverter. So it's a must that the battery voltage should be around 12.5 up, okay? So this inverter will not sound an alarm, meaning the voltage going into its input is actually very low already. Since this one is not having an alarm, meaning the voltage of this battery is more than enough to operate this inverter. Okay, I will shut off this one. Okay. Actually, we could measure the AC voltage here. Okay. We set the multitester to AC voltage. And as you could see it, the voltage is around 113.9 or almost 115 volts. Okay, 114 volts. Here in the USA, 115 volts, 114 is more than good enough. So this is an AC power already. Okay, 114 volts. So any gadget like this transformer here, this transformer is actually the power supply of my amplifier over there. Okay. Then if we try to, that's the output voltage of this inverter coming, due to the energizing of the battery. And if we try to check the voltage of the battery, hold on. The voltage is around 12.5. It's 12.5. 12.5. So this 12.5 is more than good enough. If the voltage of this battery is 12.5 up to 13 volts or 14 volts, that's very good. Meaning to say the juice of this battery is more than enough to power up this inverter. And to show you that this inverter is actually working, okay, I would like to operate my AM/FM radio. My AM/FM radio is the one on tab. Okay, the power supply of that one is actually a 3-volt battery. It's at the back. Okay, and that AM/FM inverter, I would like to make the sound larger. So I connected it on amplifier. And the power supply of that amplifier is coming from this one. So I will be using the power from the inverter to operate the AM/FM receiver with amplifier. Okay, I will shut off first this one. Okay, I plug in the transformer of the amplifier. That's the amplifier. Okay, this is the line. That's the power supply or the power transformer. And this power transformer, what it needs is actually an alternating current. So we will be getting the alternating current needed by this coming from this inverter. Okay, so I will put this one on now to on. And as you could see it, the amplifier is actually working and the voltage is 17.2. That 17.2 emanates from this. Okay, and this power transformer, is actually the power supply coming from this inverter. So it really works. During brownout, we could use this one. Okay. Okay. That's it. That's how we use this inverter to power up our power equipment during brownout. Okay, I will shut off this one now. Okay. That's the importance of this inverter during brownout. So just to show you that it works, okay, I got the power of this power supply. Okay, this power transformer that supplies the amplifier over there coming from this inverter. Okay. Okay, good evening from Los Angeles. This is the concept of an inverter and we are using it to power up our equipment during brownouts. It's not yet brownout, but I have shown you that I could power up this amplifier, okay, by using this inverter. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.